we want to look at the approaches to probability. And we are saying there are three relative approaches. And one is what we call the classical probability. Two is relative frequency probability. And three is subjective probability. And if you're looking at classical probability, we're saying that classical probability is based on the assumption that all possible outcomes of an experiment are equally likely, and that the probability of an event is the ratio of favorable outcomes with the total number of outcomes. So, like there's an example here. We're saying that if we are, let us assume that there are 1,000 residents in a town, and 5 of them received the flu vaccine. In that case, we can say the COVID vaccine. So using classical probability, we calculate that the probability of an individual receiving the flu vaccine, which is what we were calling parenthesis, as P, the probability of receiving the flu vaccine is equals to the number of vaccine recipients divided by the total population. So in that case, the probability that someone received among, if you went and sampled in your population, out of 500 people, out of 1,000 people, you have data that 500 people received the flu vaccine. The probability that an individual received the flu vaccine will be the 500 people who received divided by the total population. And it will mean that the probability that you will get a person that received a flu vaccine is 0.5. Is 0.5. So in that case, it is actually meaning that you might get someone that, if we were to sample from the definition you're seeing here, that all possible outcomes. So in this case, there are two possible outcomes. The possible outcome is that you will get someone who has not received a flu vaccine, and you will get a person who has received a flu vaccine. So the probability is 0.5. So meaning, out of every two people, one person has received and the other has not. That is what classical probability is looking at. That the probability of getting a head and a tail are equal, because there are only two outcomes. So this is an explanation of a classical probability here. What is the probability of getting a 1 from a dice? The probability is 1 out of 6, because there are 6 what? There are 6 signs. But also, what is the probability of either getting a 1 or getting a 2? Because there are two, there are two, because there are two what? Because there are two events here that are occurring, then the probability will be 2 out of 6. Because you're having two sides. You either get a 1 or you get a 2. So the probabilities are half in that regard. Meaning here, you will get either a 1 or you will get a 2. So here we are looking at the probability that you toss a 3 or you get a 4. And the probability still remains the same for all the outcomes. However, for 6 tosses, the probability that you will get either 1 or 2 or 3 or 4 or 5 or 6 is 1. So if you toss the dice like this, the probability that you will get any of the 6 figures is 1. You cannot have a 0. I don't know if that is clear. That is the regard to classical probability. So if you're looking at relative frequency probability, in relative frequency, we're looking at the probability that is based on the observation of past data or occurrences to develop probabilities for the future. And that is why we are calling it relative. Relative meaning it is looking at a period of time. We're looking at a particular period of time. So it is often used when we have a historical data that is available to make these estimates. For example, for researchers who have collected data on the incidence of a specific disease in a population over the past 5 years. So, for example, if you wanted to understand the probability that in the next month you will have women coming for antenatal for 8 antenatal visits, you have to look at your previous data. Out of the 1,000 pregnant women, how many of them came for antenatal care in the last year? Now, from that basis, you can be able to use that data. Out of 5,000 women who were pregnant, only 10 of them came for antenatal care, then you should be able to establish relatively the probability that in the next year you will have this number of antenatal visits. So, for example, we are saying here that out of 10,000 individuals who were studied, 300 of them developed the disease in the past 5 years. So, using relative frequency probability, we shall calculate the probability of an individual developing the disease as. So, if we want to know, out of 10,000 individuals, 300 people developed a particular disease, what is the probability that an individual will develop the disease? We shall say 3,300 divided by 10,000, meaning that is 0.03. So that is the probability, or that is the chance that an individual will get that particular disease. For example, if you looked at the rate at which malaria, I mean COVID-19 was spreading in the developed countries, the probability kept increasing. So as cases kept on rising, as cases kept approaching millions, the probability that someone would get COVID-19 kept increasing. And definitely you were able to see how much or how many people were infected. And this is how what people call incidence rates, or what people call the susceptibility rate are calculated, because then you can be able to establish that from this particular aspect, these are the number of people that we expect might get this disease. If we have already if we already have 2 infections of Ebola here, using probability, you can be able to establish how many more infections you will be able to have